questions 5 through 7 on the 2004 grade 12 Euclid math contest. If 16 to the power of x is equal to 2 to the power of x plus 5 minus 2 to the power of x plus 4, determine the value of x. 16 to the power of x is equal to 2 to the power of x plus 5 minus 2 to the power of x plus 4. The temptation in this question, I think, is to do a log of both sides. But the problem is, if you do the log of this side here, it's not going to help you, because the log of this 16 to the x is not equal to the log of 2x plus 5, 2 to the power of x plus 5 minus the log of 2 to the power of x plus 4. It's not equal to that. So please don't make that mistake. Because if you do that, I think, oh yeah, I know how to do this, blah, 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 and you get the wrong answer. Now, what is interesting in this question is that you could take the log of both sides, right? But it would have to be the log of the entire thing, like this. 2 to the power of x plus 5 minus 2 to the power of x plus 4. If you did that, that's fine, but it's not going to help, unfortunately, in this question. So that I just wanted to mention that really quickly to illustrate that, review your logs in terms of the rules and make sure that you don't make that mistake. So now that we've established that log is not the way to go, what is the way to go? Just use 2 factors of 2, powers of 2. I'm going to convert 2 to the power of 16 to 2 to the power of 4, which is what it's equal to. And then this one, this is very similar to that. The only difference there is a 1. So I'm just going to factor out a 2 here, 2 to the power of 1, and therefore it will be 2 to the power of x plus 4. And then minus 2 to the power of x plus 4. Okay, let's see here. This one becomes 2 to the power of 4x. And I can factor out 2 to the power of x plus 4 on this side. That leaves 2 to the power of 1 minus just 1. All right, no tricks, just basics. And then this one here is the same. Nothing you can do there so far. 2 to the power of x plus 4. And then in the brackets, it's just 2 minus 1, which is just 1. And there you go. So that means that since the bases are the same, the exponents must be equal. So this boils down to just 4x is equal to x plus 4. And therefore 3x is equal to 4. And therefore x is equal to 4 over 3. And that is the right answer. In the diagram, the parabola with equation y is equal to x squared plus tx minus 2 intersects the x-axis at points P and Q. Also, the line with equation y is equal to 3x plus 3 intersects the parabola at points P and R. Determine the value of t and the area of triangle PQR. So a little bit of labeling, perhaps. I don't think we need to do much labeling in this question, but just a little bit. I'm going to draw a line from R down to the x-axis to make it a perpendicular. And I'll just draw that it's a perpendicular. And then I can figure out the value of t, okay? And then I've got to figure out the area of triangle PQR. PQR, okay? So that basically means from P to Q, and then from Q to R, like that, and then PQ. Okay, I got it. So that means that the area of triangle PQR is going to be 1/2 base times height, as always. But what's the base in this case? It's PQ, so that distance there. And then the height is going to be that one, from R down to the x-axis. Do you want to introduce another variable? What the heck. I'll just call that S, where it touches the x-axis. I always hesitate to introduce new variables, but it's fine. It's not going to be confusing. Okay, so if we figure out t and we figure out the distance from P to Q and then the distance from R down to the x-axis, we will be set. So now let's proceed. Where would you like to start here? There's so many ways to start this question. I'll just start with this guy right here. It seems pretty simple enough. Y is equal to 3x plus 3. That's obviously a line. And it's this line right here. Right here. That line that's basically making P and R. And I think it'll be very helpful if we figure out where it crosses the x-axis. So how do you do that? Well, you set y to 0. And if you do that, we get, let's see here, minus 3 is equal to 3x, and therefore x is equal to negative 1. So this point P is negative 1, 0. All right, so we got at least a little bit of information. Now, where would you like to proceed next? Well, obviously, with this equation, that's the only other equation we have. So y is equal to x squared plus, I'm going to put a capital T, otherwise it's going to look like a plus sign, and I'll get confused, minus 2. All right, so we have to somehow figure out t, right? Okay, well, the good news is that this line and this parabola, they intersect, right? And this point of intersection we just figured out, minus 1, 0. So that must mean that minus 1, 0 is a point on that parabola. So let's substitute. So 0 for y and negative 1 for x, like that. And this should allow us to calculate the value of t. So we got 1 minus t minus 2. Bring the t to the one side, you get 1 minus 2, which is negative 1. So there you go. We've got the value for t. And now all we have to do is figure out, I guess, the triangle's area. Okay. Well, now that we have t, we basically know what this parabola is. It is y is equal to x squared minus x minus 2. Correct? Because t is negative 1. And then I think we can factor this. I don't think we need to do a quadratic. Set this equal to 0 and factor it. That way I can get my intercepts where it crosses the x-axis. So x, 2, 1, minus and plus, I believe. So this gives me x is equal to 2 or negative 1. Okay, that's a great help. Negative 1 we already know. So the other one, obviously, q, is 2, 0. All right. And therefore, p to q we can figure out. It's from negative 1 to 2. So pq must be 3. So this pq in here is 3. Now all I have to do is figure out r, and that should be sufficient to solve for the area of the triangle. How do I figure out r? Well, r is right here. It's a point on both the parabola and the line. And let's see here. We have to figure out the second point of intersection, correct? Because we figured out the first point of intersection was P. The second point of intersection between the line and the parabola is R. Okay, no problem. We just have to set the parabola and the line equal to each other. The line is 3x plus 3. The parabola is x squared minus x minus 2. And we solve for this. So put everything on one side. We get x squared. Let's see here. Minus x minus 3x minus 4x minus 2 minus 3 minus 5. And then I think this factors. Let's see here. X, 5, 1, minus plus. Yeah, minus plus. So therefore x is equal to 5 or negative 1. 5 and negative 1. Well, the negative 1 was right here. So that means this is 5. 5 something. And to get the y coordinate, we just put 5 back into either one of these. I'll just use this one since it's a little bit more simpler. Y would be, when x is 5, 3 times 5 plus 3, which is 18. So there you go. 18 is the y coordinate for r. So that means that since 18 is the y-coordinate, the distance from R down to the x-axis is 18, correct? So that means RS is 18. So there you go. We got 18 divided by 2, which is 9. 9 times 3 is 27. That's the area of the triangle. So T is -1, area is 27. Lori has a loonie, 3 quarters, 3 dimes, 3 nickels, and 5 pennies. She wishes to purchase a toy helicopter for exactly $1.34. What is the maximum number of coins that she can use to make the purchase? In Canada, a loonie is worth $1, a quarter is worth 25 cents, a dime is worth 10 cents, a nickel is worth 5 cents, and a penny is worth 1 cent. So she has 1 loonie, 3 quarters, $3, 3 dimes, 3 nickels, I'm giving her more money, and 5 pennies. A loonie is a coin. I'm old enough to remember when we didn't have a loonie. We had a paper note for $1, but that was a long time ago. Now we have a situation where she has to purchase something that's worth $1.34. I'm just going to convert it all to cents. It makes it a little bit easier. 134 cents. Now, one thing I immediately noticed is that we have to figure out the total value of her coins. And how many does she have, first of all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. She has initially 15 coins. All right, now I want to figure out the total value of her coins. So it's $1 plus 75 cents. I'm going to convert this to cents. 3 dimes is 30 cents. 3 nickels is 15. And then 5 pennies is 5. And this looks like 225 cents. So she has 225 cents and she wants to spend 134 cents. So she definitely has enough money. But one thing I noticed is that if you take out the loonie, you just say, look, I don't want to count this loonie. Can I do this with just the remaining coins? She will only have 125 cents. And that is not sufficient enough to buy that toy helicopter. So she must use her loonie. So the loonie absolutely has to be used. Okay, that's fine. So if she absolutely has to use the loonie, that means of this 134, only 34 cents remain that we have to figure out how to create with the remaining coins, and do it in a way that we use the maximum amount of coins. All right, no problem. This is just, one of those trial and error, fiddle around and see what you get. Okay, I want to use a lot of pennies because the smaller the unit is, the more coins I can use. Can I use all 5? I could, but then this would come down to 29, and there's no way for me to get 29 cents with the remaining numbers because they're all divisible by 5 or 10, you know what I mean? So I'm going to use 4 pennies. I think that is a good choice. If I do use 4 pennies, how much money do I still have to come up with? Well, 4 pennies is 4 cents, so I've got to now come up with 30 cents. All right, I got to come up with 30 cents using quarters, dimes, and nickels. Well, I don't want to use a quarter because that's going to use up too much money, because the key to this question is they want you to use the maximum number of coins. Let me see if I can use nickels. Can I use 3 nickels? If I use 3 nickels, I'll have 15 cents remaining, and there's no way to make 15 cents with dimes and quarters. So I'm going to use 2 nickels. If I do that, how much money do I still have to raise? 2 nickels is 10 cents. So I still have to raise 20 cents. And I can do that with 2 dimes. And I think this should be the answer. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 coins. It's one of those trial and error questions. I'm confident that 9 coins is the maximum for this question. Digital images consist of a very large number of equally spaced dots called pixels. The resolution of an image is the number of pixels per centimeter in each of the horizontal and vertical directions. Thus, an image with dimensions 10 by 15 centimeters has a resolution of 75 pixels per centimeter, has a total of 10 times 75 times 15 times 75, which is equal to 843,750 pixels. If each of these dimensions was increased by n% and the resolution was decreased by n%, the image would have 345,600 pixels. Determine the value of n. So this is one of those questions where you have to be comfortable with percentages. And in particular, how do I create that formula knowing that I'm increased and decreased by a factor of n for dimensions and resolution respectively? Well, they give you part of it. They tell you that the number of pixels will be 345,600. And now we have to sort of figure out this formula using n. All right, well, the first part is 10. The dimensions have not changed in terms of the base dimensions. We are increasing this image by a certain amount, so we can still use 10 and 15. We just have to ensure that we increase them. 10 is being increased by n%. So that means it would be 10 times 1 plus n over 100. Okay? And then we get to the 75, which is this guy. All right, 75 is talking about the resolution. That is being decreased by n%. So that means you'd have 75 times 1 minus n over 100. Okay? And in a very similar way, I will try to squeeze it all in. I actually don't need to keep putting in this x. I'll just put brackets. 15 centimeters, but we are increasing this time by n%, so it's 1 plus n over 100. And then finally, we've got 75 for the resolution that is decreased by n%. So 75 times 1 minus n over 100. So there you have it. That is your formula. And we have to now determine the value of n. So we basically just have to solve for n. So 3, 4, 5, 6, 0, 0. What I'm going to do is I'm going to put all the numbers out front. And then I'll just have n. So I got 10 here, I got 75 here. I've got the 15, and I've got the 75, right? And then that leaves me with 1 plus n over 100. And then I think there's 2 of them, right? Okay. And then I've got 1 minus n over 100. Correct? And there's 2 of them. There's 2 of these guys and 2 of these guys. So that's basically all squared if you were to kind of put it together. Okay. This number here, I'm going to figure out that number and then put it underneath this guy here. And if you do that, you basically get 0.4096 like that. And that leaves me with 1 plus n over 100 times 1 minus n over 100. And this is all squared. All right. Now take the square root of both sides, and if you do, this side becomes 0.64, and this side, the square root just disappears like that. And at this point, we are almost done here. I just have to expand this guy on the right side. So this becomes 1 minus plus, those cancel, and it's just n squared over 100 squared. Okay. Put the n squared over 100 squared on the other side. Bring the 0.64 over like that. This becomes, of course, 0.36. And this is n squared over 100 squared. N squared, therefore, is 0.36 times 100 squared. And I think that's it. Now you just do the math for this big number and then take the square root, and you'll get n is equal to 60. Okay? So it's a very important question because you're going to be dealing with percentages a lot. So if you can set up the question the way I did it, then it's pretty straightforward after that. In the diagram, AC is equal to BC. AD is 7 and DC is 8. And ADC, that angle, is 120. What is the value of x? So here's that diagram blown up a little bit. And in this question, I immediately recognize that we are going to use the law of cosines. If you are not familiar with the law of cosines, I will give you a crash course. If you have any triangle, right, and it doesn't have to be a right triangle, it could be any triangle. It doesn't have to be isosceles or equilateral or anything. Just any regular triangle. And you've got three sides, ABC, and you know this angle right here. If you do, you can take that angle to figure out the different sides. And the equation is c squared is equal to a squared plus b squared. So far it looks like Pythagoras, right? But this is not a right triangle. So because it's not right, we have to take into consideration the angle and cos of this angle right here, which is, I'll just call it theta. Okay, so that's the law of cosines. And we are going to use that law of cosines on this triangle right here. They've set it up for us beautifully, exactly the way that the law of cosines is. All right, so let's do that. We have to figure out AC, right? So that means AC all squared is equal to a squared. In this case, that's 7. B squared is equal to 8 squared minus 2 times 7 times 8. And the cos, they give you the angle, is 120, right? So now you just crunch out the numbers here. 49 plus 64 minus, let's see, 112. And then cos of 120 is a negative a half. So this becomes 49 plus 64 plus 56. And that is 49, 64, 56, 169. And therefore AC would be the square root of 169, which is 13. So AC is 13. Now these little symbols mean that those two sides are the same. So this is therefore also 13. Now how do you figure out x? Well, this is a right triangle. So you do not have to use the law of cosines. You can just use Pythagoras. So 13 squared plus 13 squared is equal to x squared. This looks like 169 plus 169 is equal to x squared. And that is 338. And therefore x is equal to the square root of 338. And 338, of course, can be written as 13 root 2. Right? Because it's 169 times 2. So there you have it. There's the value for x. In the diagram, a drawer, PRST, that is 11 centimeters high, is in a long slot, ABCD, which is 15 centimeters high. The drawer is pulled out so that the midpoint of its base rests at C. The drawer is tilted so that the top back edge of the drawer touches the top of the slot. If the angle between the drawer and the slot is 10 degrees, determine the length of the drawer to the nearest tenth of a centimeter. This diagram is at the heart of our question. So let's start. Let's label a few things. We are required to find this length, correct? So they've given us a little bit of a clue there that those two are the same. So I will just say that this here, TC, is x. I'll just label it x. And therefore, since we have to figure out the value of TS, and TS is just going to be x plus x, we essentially have to find the value of 2x. Okay? So that's what we have to find. We want to make that clear. And then now, where do we proceed? Well, every piece of information that they gave us is labeled already. And this is 15, and this is 11, and that's 10 degrees, that angle right in there. And then because these are rectangles, this is of course 90, this is 90, and so on, right? I mean, that doesn't really need to be labeled, it's kind of obvious. So the rest I'm going to have to put in some variables. So far I put in the x's. This one here, from B down to there, Q, right? BQ, I'm going to call that guy Y, because that's definitely going to be needed. And then that means that Q down to C is 15 minus Y. 15 minus Y. Okay? And then I'm going to use this angle. I am pretty confident that angle needs to be used. Otherwise, they wouldn't have given it to you. So if that's 10, that means this angle in here is 80. All right? And therefore, we can use those angles to figure out the lengths of the sides using trigonometry. All right? And I want to figure out PB. I wish I could figure out the numerical value, but I can't. But I can use trigonometry at least to get it in terms of y. So we've got tan. Tan would work. Tan of 10 degrees is equal to y over PB. And therefore PB is equal to y over the tan of 10. Okay? So this is y over the tan of 10. And if I need anything else later on, I can always fill it in. But for now, I think I should be okay. Now, I'm going to draw a line from P to C, like that. Okay? And immediately I see that there is a triangle here with a right angle, PBC. And in that triangle, because there's a right angle, I can use Pythagoras. So I've got PB squared plus BC squared is equal to PC squared. Right? So PB, we got what? Y over the tan of 10. And then BC is 15. Correct? Because it's the same as that length. So that's very helpful. And then PC, well, that one we don't know. So we have to calculate for that. And this looks like I forgot to square that. Okay, don't make that mistake. So PC, let's see, y squared, tan of 10 squared. So tan of 10 all squared. And then 15 squared is just 225. And then here, if you do the math, you're going to get 32.163. Like if you take the tan, square it, and then flip it. And then you get a number, and that's y squared plus 225 is equal to PC squared. And that's about as far as I can go there. All right. Now at this point, I'm going to draw another line, and that line is going to be parallel to PT. So if this is PT, I'm going to draw it parallel, but coming from C. So from C, parallel to PT like that. Okay, I hope that makes sense. And therefore, this is a right angle right there because I drew it parallel. All right. Now, I'm going to draw that again, but over on the side just to make it less, how you say, confusing, or there's just not enough space for me to draw in what I need to draw. So that's that triangle right there. And that triangle represents this guy right here. Okay, that little one that's very narrow. Now, this is, of course, a right angle. This side from here to here is 11, right? Because it's the same as PT. And then this side, I figured out earlier, I gave it sort of a value of 15 minus y. Okay? And then this angle in here, we can figure out it's exactly opposite to the 80. I hope you can see that right there. So therefore, it's 80 degrees. And then this one, process of elimination is, well, actually, that's not the best way to describe it. By, the sum of the angles being 180 is 10. So this is very helpful because we can now use a very basic trigonometry formula to figure out the exact value of y, which is what we definitely need. And I'm going to use cosine. So the cosine of 10 is equal to adjacent over hypotenuse. So it's 11 over 15 minus y, like that. So that means that 15 minus y is equal to 11 over cos of 10. And that means 15 minus y, if you do the math here, it's 11.169, and therefore y is equal to 3.8303. Okay? And there we go. We have pretty much come to our point where we can figure out this question. We got y is here, now we can figure out PC. So substitute y is equal to 3.83 into here. You got 32.163. Y is 3.83 all squared plus 225, like that. Okay. If you do that, you'll get 696.871. And then if you take the square root of that to get PC, you'll get approximately 26.398. All right, now we're at a final step, which is trying to figure out x. How do we do that? Well, we've got a Pythagorean relationship in that triangle. And that Pythagorean relationship, I'll just try to squeeze it in first, is pt squared plus tc squared is equal to pc squared. Pt is 11, tc is what we want to figure out, x, and pc we just figured out. We actually got the exact numerical value. We've got 26.398 all squared. Okay, so let's do this now. X squared is equal to 26.398 all squared minus 11 squared, like that. And this will give you 575.85 for x squared. And then of course you got to take the square root of that. And if you do, you get 23.99. I guess it's 24, but the way I did it, I probably missed out a few decimal points, but that's okay. And what do we want to figure out in this question? The whole length, right? Well, I just figured out x. The whole length, I wrote it in the beginning, is 2x. So therefore 2x is equal to 2 times that, which is 47.99. Determine the length of the drawer to the nearest tenth of a centimeter. All right, well, to the nearest tenth of the centimeter, it would probably just be 48.0. So there you go. That's the answer.